Good morning, dear students. Today we are going to continue the chapter Permutation and Combination. And in the earlier classes, we have studied that permutation and fundamental principle of counting and multiplication principle, that is, and permutation we have discussed. Now we are discussing combination. Let us say there are three objects and we are selecting two at a time. So basically the difference is, if we are talking about permutation, that means we are talking about the arrangements, whereas if we are talking about the combinations, that means we are talking about the selections. So arrangement is different and selection is different. So what we are doing is, we are talking about the selection. So basically, if we select for person or object, let us consider if we are making any team or committee. So for that particular thing, we have to select some people to be a part of that team or that committee, and in that particular manner we will discuss these things. Let us assume there are three person, and that these are x, y and z, and what we are doing is we are making a team of 2% or committee of 2%. Then how many ways we can frame a committee? There, that is nothing but xy, yz and zx. Now we will discuss, if we have selected xy, then what is the, and yx, if we arrange in that manner, then it is whether that is a different thing or equal thing. So if we consider a team of that consists of x and y, and or y and x, so both are the same thing, not the different thing. Therefore combination of three different objects taken are at a time, sorry, two at a time. So combination of three different objects taken two at a time, that can frame a three combination over here. We cannot make more combination than this, whatever available over here. So here order is not important, whereas in permutation order is very important thing. Now coming to the second point, that is formula for finding the number of combinations of n different objects taken are at a time, denoted by NCR. It is read as NCR. It means factorial n whole divided by n minus r factorial into r factorial. This is the denominator. So this is the formula. This is a very important formula. One should remember this one. Now coming to the theorem 5, it states, what we are doing is we are taking the relationship between permutation and combination. What is the relationship? It states that only if we are considering this as permutation, this as combination. So in combination we have just selected the people, and what we are doing is in permutation we'll arrange that also. Means if order also matters, means x is coming first or y is second, that is one order. Then y is coming first and x is on second position, so that will be another order. Whereas in team there is nothing much as different, there is nothing difference if whether x is first or y is first. So x and y both are in the team, that is sufficient. So it is like that. And r that belongs to 0 and n, where n is r can be equal to n. So we can put the value of r till that. So npr is equal to ncr into factorial r. And after this theorem we'll have some remarks over there, or note it then, where when r is equal to n, then we will be having ncn, that is n factorial divided by n minus n factorial into n factorial. As per the formula we have written over there, replaced r by n. So we got that. Then n minus n is 0 factorial, and definitely it will be equal to 1, as each n factorial and n factorial will cancel each other. We know that in the last class or in the last video lecture we have studied that, or we have seen that 0 factorial is equal to 1. Similarly, note number 2, that is nc0 is equal to 1. We can put 0 over there in the place of r, so it will become 0, it will become 0, 0 factorial. This will give us 1, and this is n factorial. So n factorial divided by n factorial will give us 1. So in the both the cases, what we are having is 1. NCR is equal to NC n minus r. So we will describe this in this topic or in this point. NCA is equal to NCB. If we consider, then that must be A equal to B, or A plus B is equal to N. Why it is so? So we will see that if we are saying that out of n object, if we are selecting R object, that means what we are doing is, out of n object we are rejecting n minus R object. So it is like that only, whether we are selecting or we are rejecting, both are the same thing. Here also the same thing. If A and B both are equal, then okay. If that is not, then A plus B is equal to N. Now theorem 6, it states that NCR plus NCR minus 1 equal to N plus 1 CR. So this is one of the very important formula we are going to use while solving the question. Whenever we will come across this one, we will use that as a formula. So I have written the proof over there, how we can get this plus this is equal to this. So it is nothing but NCR plus NCR minus 1. So I have expanded by using the formula for this. So this is factorial n divided by n minus r factorial into r factorial. Here plus n factorial divided by n minus r plus 1 factorial. This is r minus 1 factorial. Here I have written directly, this is nothing but, this term is nothing but n minus r minus 1. It is like that. So while opening the bracket, we will get this one, n minus r plus 1. So this is after that, this is equal to n factorial. And what I have done is, I took r as a common from this entire term from here. So what I have is n minus r factorial is there. Here I'll get r minus 1 factorial, as r is I have taken out, and here this is n factorial and this is r minus 1. I have written over here the same thing. You can see here n minus r plus 1 factorial is there. So what I have done is n minus r plus 1, this is the thing, then after that multiplied by this factorial n minus r, so 1 less than that. So in these two terms I have taken common n factorial and n minus r factorial, this one, and r minus 1 factorial. These two terms are common. You can see these two terms are common. Here n minus r factorial, r minus 1 factorial, and r minus 1 factorial, n minus r factorial, and here this is n factorial, n factorial. So this is the common, and remaining thing is 1 by r plus 1 divided by n minus r plus 1. So after taking LCM, we will be having n minus r plus 1, this entire term over here, and this term over here. So r plus and minus we are getting, so it will cancel each other. So what we have is n plus 1 over here. So if I multiply n plus 1 to the n factorial, it will become n plus 1 factorial. Now r, if I am going to multiply with r minus 1, then it will become r factorial. So I have written r factorial over here, and this is the thing, n minus r is there, and n minus r factorial is there, and n minus r plus 1 if I'll write, then this is, I can write the factorial of n minus r plus 1, and I have arranged this in this manner, n plus 1 minus r. So this is nothing but, if I compare to the formula, this is the nothing but formula only, n factorial divided by n minus r factorial into r factorial. So I have the same thing, n plus 1 factorial divided by n plus 1 minus r factorial into r factorial. So what I have is this one I have. So it is proof that NCR plus NCR minus 1 is equal to n plus 1 CR. Now we'll consider one example. If NC9 is equal to NC8, then find NC17. So we'll apply the formula over here, n factorial divided by n minus 9 factorial and into 9 factorial. Over here, n factorial divided by n minus 8 factorial, 8 factorial. So n factorial get cancelled each other. So we will get 1 over here. Now what I'll do is, if I'll take 9 from 9 factorial, it will become 9 into 8 factorial. So 8 factorial and this one get cancelled. If I'll take common from here, that is n minus 9. So it will become n minus 9 into n minus 8 factorial. So again this one and this one get cancelled. So what I have is, sorry, I made mistake. From here what we will do is, we will subtract one more number and we'll get n minus 1 factorial. As if we take common n minus 8 over here, then definitely the number will become lesser and lesser and lesser. So now n minus 8, this is n minus 8 into n minus 1 factorial. So this will cancel with this term. So what I have left is, in this side I will be having n minus 8, and in this side I will be having 9, this one. So 1 by 9 equal to 1 by n minus 8, and n is equal to 17. Therefore we know that we can explain this also, 17 factorial divided by 17 minus 17 factorial into 17 factorial. This will become 0 factorial, 17 factorial, 17 factorial will get cancel each other, and this will become 1. So this is our answer. We'll also have one more solution for this, as we noted down remark over there that NCA is equal to NCB. If given like this, then we have n equal to a plus b. Directly we can use this term also, and we know that n equal to 9 plus 8, this will give us 17. So we can use this formula also, and we can solve by this method also. Now we'll solve one more question. We have to form a committee of 3 persons from 2 men and 3 women. So how many ways we can frame a committee? So we will see that total number of person over here is 5, and we have to make, or we have to select, out of that 3 we have to select. So it is basically 5 factorial divided by 5 minus 3 factorial into 3 factorial we will be having 5 factorial divided by 2 factorial into 3 factorial. This is our selection. Or more over, if I say 5 into 4 into 3 into 2 into 1 divided by 2 into 1 into 3 into 2 into 1. So 3 2 3 2 2. There are 10 ways which we can frame a committee of 3 persons out of 2 men and 3 women. Another part of this question, I have to make committee of 3 persons and I have a condition that I should choose 1 man from out of these 2 and 2 women out of these 3. So what I am doing is, I have 2 men over there, I am selecting 1, and what I am doing is, I have 3 women and selecting 2 over there. So what I have is 2C1 2 factorial divided by 2 minus 1 factorial into 1 factorial plus 3 factorial divided by 3 minus 2 factorial into 2 factorial. So what we will have is 2 factorial is nothing but 2 into 1. Then 2 minus 1 is 1 factorial, 1 factorial. So 1 into 1 will get the same thing. 3 factorial will get 3 into 2 into 1. And 3 minus 2 factorial is 1 and this is 2. So 1 into 2 into 1. So there is 2 plus 3, that is 5. It is not plus, it is multiplication. This is answer. Likewise, you have to solve all the questions in exercise 7.4. We are stopping here and we will solve some more questions during the class.